Okay, so here's the sample problem that we were working on in class. If you take a look up here, this is a project at Bell High School where they have 100 wind generators, each with a power output of 1.5 megawatts. We're going to have to convert that to watts later. Electrical demand is expected to be 3.0 times 10 to the 5th megawatt hours annually. Okay, so calculate how much energy the wind generators would need to produce to provide 33%. Okay, so if we know that the total demand is, this is for part A, if we know the total demand is 3.0 times 10 to the 5th megawatt hours. In order to find 33% of that, we would simply multiply this times the decimal form of the percentage, which is 0.33. If we put that into our calculator, 99,000 megawatt hours. Okay, for B. If each kilowatt hour is 35 cents, how much total revenue would the generators produce if they were able to provide that 33% of the total electrical demand? Well, the problem here is that the conversion factor is kilowatt hours to 35 cents, but we have 99,000 megawatt hours. So let us convert megawatt hours to kilowatt hours. And in order to do that, we're going to take 99,000 megawatt hours, draw your vinculum, and if we have megawatt hours in the numerator here, we need megawatt hours down here. If you remember, our conversion factor is 1 megawatt is equal to 10 to the 6th watts. So we'll put that right here, 1 megawatt, 10 to the 6 watts. These will cancel. And let us now convert watts to kilowatts. And we are going to put, we know from our yesterday's example that 1 kilowatt is equal to 10 to the 3rd watts. Oh, one thing that I shouldn't have done is put hours down there because I want the hours in the numerator at the end. I don't want that to cancel out. So we're going to have 10 to the 3rd watts is 1 kilowatt. Excuse my poor penmanship. Those will cancel. And if we put those into the calculator, I get 9.9 times 10 to the 7th kilowatts times these hours right here, kilowatt hours. Now, this is actually going to be useful for me in part C. So I'm going to keep my eyes on this because I'm going to want this later. So I'm going to take these kilowatt hours, and my conversion factor right here is, set this up to cancel. If I have kilowatt hours here, here's my vinculum. I have to have kilowatt hours in the denominator to cancel. And for every 1 kilowatt hour, there is a cost of 35 cents. And so I'm just going to multiply that across, cancel that out, and I should be left with $ signs at the end. I am going to get, let me write this in black, 3.465 times 10 to the 7th dollars. That should be, oops, clean that up a little bit. 3.465. Like that. Oops. Yeah, perfect. Dollars. Okay. Now, for part C, we want to find the number of hours, and this is the formula that we can use for that. kilowatt hours, which we already found, is equal to total watts times hours divided by 1,000. All right. So let's see what we have here. I can fill this in with what I have. I know that I have 9.9 times 10 to the 7th kilowatt hours. We already did that. So it's going to be 9.9 times 10 to the 7th kilowatt hours. It's going to be equal to my total watts, which I don't know yet, times hours divided by 1,000. Now, the reason I don't know my total watts is because I have 100 wind generators at 1.5 megawatts. So that's easy. So I take my 100 wind generators and abbreviate it. And every one wind generator, aka turbine, is 1.5 megawatts. And that's fine, except I don't want megawatts. I want kilowatts. And so I am going to have to use these two conversion factors right here to make this kilowatts. So 1 megawatt is 10 to the 6 watts. 10 to the 3rd watts. Oh no, that's actually as far as I need to go because I need it in watts, and I am there. One step. So if I put that into my, I get 1.5 times 10 to the 8th watts. And I can use this in my formula. So I'm going to bring this here. And let me do that. 1.5 times 10 to the 8th watts. It's going to fit in here somewhere. Watts. Okay. Now, solving for hours. I got to multiply both sides times 1,000 times my kilowatt hours. And then I'm going to divide that by 1.5 times 10 to the 8th. And that should give me my hours, which if I put that in my calculator, should be 660. Let's see. $660. The end.